Before I start this video, let me take 30 seconds to tell you something about Exergic. Exergic is India's most trusted and most experienced institute for online GATE preparation. I am Chandresh Mahajan, founder and chief educator at Exergic. I am an All India rank 37 in GATE Mechanical Engineering, an ex-Indian Oil officer having 7+ years of teaching experience as of now. To know more about our GATE courses, you can visit our website or contact us on these details. Also, you can download Exergic GATE Preparation app from Google Play Store. The link is available in the description of video. Now let us have a look at this question which mentions a 2 kg wheel. Mass is given and it's a wheel is rolling without slipping, pure rolling, with its center's velocity of 0.3 meter per second. So you can see this is a wheel, it is doing pure rolling without slipping, and the velocity of its center, let's say O is the center, so velocity of center is 0.3 meter per second as shown, means in the downward direction, and it is doing pure rolling, so obviously it has some angular velocity as well. When a force of 10 Newton is applied to the cord as shown below, so you can see that there can be some cord which is connected at a certain point on the wheel, not at the center, at some distance from the center some cord maybe is attached, and then there is a force P of 10 Newton, which is applied at that cord. This point is at a distance of 0.03 meter, you can say, or 30 mm from the center. And how much is the radius of the entire wheel? It is 80 mm or 0.08 meters, correct? If the wheel has a radius of gyration of 60 mm, so question has also given you the value of radius of gyration of the wheel 60 mm, or you can say 0.06 meters about its center. Calculate the velocity V of the center when 10 Newton force has been applied for 5 seconds. So when this force of 10 Newton has been applied for over a duration of 5 seconds, obviously there will be certain changes in the dynamics of the body, in the kinematics of the body. The body, its velocity will obviously change, and question is asking you what will be the velocity of center of this wheel of point O when you have applied the force P of 10 Newton for 5 seconds here at a distance, you can say, of 30 mm from the center. This is what question has given and question is asking you. One more data that you can see from the diagram, not mentioned in the question, that this is not rolling on a flat surface but it is doing pure rolling on an inclined surface. And how much is the angle of inclination? It is 15 degrees. Now what I expect every time when I post a question, when I discuss any question in the course, that after going through the question, pause it and just try to solve it on your own. That will increase your understanding of the question, your learnings from the question. And let me tell you, there are more than one ways to solve this question. Rather, I will be discussing 3 different ways to solve this question. You can consider this question maybe as a question of angular momentum, maybe as a question of rolling, maybe as a question of energy balance. There are multiple ways. I have given you some hint also, right? So try to solve it on your own. There are more than one ways to solve it. Pause the video, and obviously if you need any hint at any point of time, you can just play the video, listen to me talking for some moment, and then again pause and then try to think. That is the best way in which you can absorb maximum from my solved examples, from my questions. Alright. So the very first thing in any of the mechanics questions is to understand the free body diagram. Right. So here is the free body diagram. What we have done, that the incline we have removed, correct? And in place of incline there will be a normal reaction, correct, which will be along the common tangent like this, moving towards the center. In this direction normal is directed, right? There is weight component, as you can see, W component here. And since it is on an incline, there is one more way to represent weight. What is that way? Mg sin theta here, Mg cos theta here, right? So weight can be broken down into two components along the incline and perpendicular to the incline. W sin theta, W cos theta. That can also be done. Rather, we will do that later on. There is one interesting point to note here before we even begin discussing this question. What should be the direction of friction? In the question, nothing has been mentioned to you. Question has not mentioned anything about the direction of friction. And those of you who don't have proper understanding of rolling may struggle in this question. But if you recall, I have clearly discussed this concept in one of the earlier lectures. What I told you, that don't think that if question has given you pure rolling, there will always be zero friction. That is not the case. It depends upon many different factors. The force being one of the factors. Where exactly force acting? Where exactly is the force acting? So in this situation, you can see that there is not one but more than one force is acting. Obviously one force you can see P here, but you also know that Mg sin theta is acting in this direction, Mg cos theta is in this direction, right? So there are more than one forces acting, so you cannot simply say that sir it is doing pure rolling so friction will be zero. That is incorrect concept. We have discussed that already. So here friction obviously is not going to be zero, friction will exist. But what will be the direction of friction? What will be the value of friction? That we need to figure out, right? So that is why here what I have done, that I have shown a direction of friction, any direction. If you want, you can show it like this also. I have shown it like this, correct? But right now the task in front of you, even before you start solving the question, even before you start solving the question, trying to find the effect of P on velocity, the first thing is free body diagram. And in the free body diagram, you need to find out not only the direction of force but also the value of force, because it can be in the upward direction also, down the incline also, different values are possible. So this is one extra step at this point of time. I will do that and tell you how you can do that. But here at this point of time, I am going to solve it by a different approach that will be slightly easier and slightly it will require lesser calculation. You won't be requiring to find out the direction or the value of friction. How interesting, how simple, right? And it is very easy to do that by simply taking the moment about point C, about the point of contact. Generally, whenever we discuss rolling, I'm sure you have seen throughout the lectures that whenever we are analyzing the moment, we do it about the center, right? And it is very much logical also, because rolling is a combination of translation and rotation. Translation anyway does not matter, it's going to be complete translation, but rotation about the center. So when you combine both of them, then the net vector sum that you get gives you the dynamics of pure rolling, right? Something that we have already discussed. So it is logical that when we are doing complete pure rolling analysis, by breaking it down into translation and rotation, when we do it, the rotation component has to be about O. There you cannot take the rotation about this point, you will get the wrong answer for sure. But here, the approach that I am choosing right now is not the rolling approach. The approach that I am choosing here right now is not the rolling approach. Rather, the approach that I am choosing can be called as the principle of angular momentum, application of angular momentum rather, for a rolling body. So how to apply principle or concept of angular momentum for a rolling body, that I am discussing here. I am not going to discuss it by the concept of pure rolling, but by considering the momentum, the angular momentum of this rolling body about the point C. That is the concept that I am going to use here. So I will not be breaking down the rolling into translation and rotation about O. That is why it is possible for me to do this and to take the moment about point C. It is very important to know. Many students do such kind of mistakes in solving question. In fact, in GATE, some of the students have done this mistake a couple of years ago, that rather than analyze, they were trying to analyze the pure rolling case, translation, very simple, but for rotation they chose this point. That is something that can cause mistakes, that can cause blunders, because when you say pure rolling, it is breaking down of translation and rotation about the center. But here we are not analyzing like that. We will do that. We will do this analysis. As I told you, there are more than one ways that we are going to discuss here. So that approach also we will discuss. But right now we are discussing the angular momentum concept, applying angular momentum concept about point C, about this point. So benefit is one lesser equation. How? Because translation you don't have to cover now. Only rotation part we will see about the center. One benefit that we have got. Next benefit, that we don't need to find out the value of friction. We don't need to bother about the direction of friction. Whether it exists, it does not exist. If it exists, what is the direction? What is the magnitude? Nothing we need to worry about, because now the approach that we will choose, we will take the moment about this point C, which will nullify the moment of F, because it is passing through the point C. Got it? So if we apply the concept of angular momentum about point C, what can we say? That net moment about point C is equal to mass moment of inertia about point C multiplied by angular acceleration about point C. Correct? Just like we have net force is equal to mass multiplied by acceleration, same concept applied about point C. Right or not? Now, what is the net moment about point C? That we will discuss slightly later. But as of now, let us try to slightly modify this equation. Why? Because have you been given the value of alpha? Has question given you the value of alpha? No, question has not given you that. So you need to break that down. You need to convert alpha to omega, to angular momentum, and then angular momentum will be related with velocity v. That's how we are going to get to the answer. If you look at the question, what is the question asking you? It is asking you the velocity of the center. It is asking you the velocity of the center. Correct or not? So to reach that velocity v, we need to come slowly from alpha. So we will come from alpha to omega, then from omega to v, and that's how we are going to find that value of velocity of center. So here what we can do, alpha we can write as d omega by dt. Correct? And this dt, if I bring on the left hand side, this is the equation that I will get. And this is the point where we get something interesting, that if we integrate this, then this is the expression in front of us. Correct? If we put the integration sign on both the sides. Why is this important? Because there can be certain questions where you may not have a fixed value of moment. For example, here you will see very soon that moment is not changing about point C. Why? Because all forces are same, the distance at which they are acting are same. Right? Moment is force multiplied by the distance, minimum distance or perpendicular distance from the point, right, between the line of action and the point. So force is not changing, the distance is not changing, so moment obviously is not going to change. Correct? But there can be some cases where you may have a variable force. In those cases, this equation is going to be helpful. I am not asking you to mug up this equation or to learn this equation, but this is one possible way in which the simple equation can get modified and be used for the cases of variable moment or variable force acting as a moment. Got the point? Now here you will see very soon, in fact at this point only you can see all the forces P, weight, N, F, all the forces are not changing. So moment and distance also, the point of application is also not changing. So this anyway is a constant. So this will come out of integration, and then you will have different integration of dt, which will be t, which will be t2 minus t1, basically the duration during which the moment or forces were acting. Right? So that I have written like this. On the right hand side also, this is a constant, it will come out of integration. All you will have is delta omega. Correct? So this is the equation that we have got. This we need to find out how much is the summation of moment about point C. Delta t is known to us. 5 seconds. Question asked na, what will be the velocity when it is applied for 5 seconds? So for a duration of 5 seconds, delta t is 5. IC we need to find out. IC is mass moment of inertia about point C. How we can find it out? Because for this case, radius of gyration has been given to us. Radius of gyration is 60 mm. So this is about its center, about O. So about O we know that it is mk square. If we need to find out the I about C, about this point C, What concept can we use? We can use parallel axis theorem. So this is the line about which, this is the line coming out of the whiteboard, about which we know the value of mass moment of inertia about the center. If we want to shift it from here to here, this is the distance between them, right? The lines are coming out of the smart board like this. So about this O we have mk square. About C it will be IO plus m multiplied by this distance squared. Let's say capital R is the distance. Here let's say capital R is 80, this 80, this bigger radius, and this small radius at which this P is acting, that small r is 30. So this equation mk square plus m capital R square. M is known, k is known, capital R is known. So you can find out the mass moment of inertia about C like this. So here this is the IC value which we already know. As I told you, delta T we already know. Delta omega, let's see whether we know that. Initially we know how much is the center velocity, right? Omega value is equal to, at this, about this point C, right? Please note that we are considering the moment, the angular momentum, everything about this point C. So about this point, how much is the value of omega initially? Velocity is 0.3 divided by r. Rather I'll say magnitude of omega. I will come to the direction in a moment. So magnitude of omega about this point initially is this velocity divided by r. And later on, again the magnitude, this let's say is initial and this is final. Later on, this velocity we may change, it will change. That's what question is asking you. What is the velocity after force has been applied for 5 seconds? Let's say that velocity is v, right, divided by r. So this is the initial value of magnitude of initial omega. This is the magnitude of final omega, right? You can see how omega and v can be related easily here. R is known to us, V naught is known to us, correct? So here delta omega is nothing but the difference of angular velocities about this point C, which is the difference of these two values of these two. I will talk about the sign. So it gives you an idea that here delta T known to us, IC known to me, net moment about point C, it is known to you. You will see that in next step. Then in the expression of delta omega, only this V is the unknown, and I can find that out. Very simple, correct? Only one equation we have used here, this equation only, right? And it is going to lead us to the answer. But trust me, when this question comes in exam, many students will not be able to do because of some confusions and some lack of concept regarding where you can apply which moment. So these things are important, especially in such questions where there are multiple ways to solve. So what happens, student mix the approaches, right? When there are more than one ways to solve, we are going to solve it one by one way, where about O we are going to take the moment also. And here we have taken the moment about C. But when there are multiple approaches, without knowing the right concept, you can mix up the different concepts. And that's an error that good students also have done in past GATE. You need to be careful about that. Before moving further, quickly go through this calculation. We have already discussed this logic and concept. Right? The value IC about C is mk square plus m capital R square. K is 60 mm, 0.06 meter. R is 80 mm, 0.08 meter. Mass is 2 kg. Put the values, solve. You will get IC as 0.02 kg meter square. Got it? So this value is sorted for us. This is 5. Coming to this value, net moment about C. Okay. So again, I have slightly simplified the diagram. I have only shown the forces and all, right? The distances 0.8 and all that I have not shown here. So you can see that weight has been reduced to mg sine theta like this, because as I told you, weight in such cases have two components. You can resolve them into two components. Anyway, you can show two components, but here you can resolve them into two logical components, one along the incline, one perpendicular to the incline, which is mg sine theta and mg cos theta. Mg cos theta I am not showing because I am going to take the moment about C. Mg cos theta is going to pass from the C. It will not have any impact on that. So only mg sine theta I have shown here, correct? Now, when we talk about the moment, it's very important to be clear about the direction. Even when we will discuss omega, we need to be clear about the direction. Why? If you recall, Just take the analogy of simple translational cases. In case of translation motion, we need to know that which direction we are considering positive, right? If I am applying the force in a certain direction, body is accelerating in a certain direction, what velocity change is occurring, what was the initial velocity, what is the final velocity, what is the direction of x, accordingly we write the equation, right? Similarly here also we need to be clear about the direction, whether we are considering this rotation, let's about c we are considering the rotation, right? Be very clear in that. So this about c, the clockwise we are considering as positive or counterclockwise we are considering as positive. So here what we have done, the clockwise motion we have considered as positive. We have assumed that this body under the action of the force, this P, is going to have an alpha in the clockwise direction. It may or may not have. Your answer will come negative. If you have what you are considering is not correct, your answer will come out to be negative. But you have to write equations according to that only. Your answer will come correct only when everywhere you have used the same notation. Correct? That's why it is important to consider the notation, decide the notation, and use the same notation for all the calculations. Otherwise, if you have this idea in mind that always answer will tell us whether we consider notation correct or not, so that is not right, because it is possible that here while doing this you will apply some other notation, and while doing this you will apply some other notation. So it is possible that you will use different notation in the same equation, which ultimately give you incorrect answer. Forget about the plus or minus sign, incorrect answer. So it is important for you to know that you can choose the notation as per your convenience, but notation should be coherent. It should be similarly applied, at least in the same equation. Now let me pick up my pen and then I will continue. So as I told you that about this point C, we are assuming that clockwise acceleration is existing, and that direction we are taking as positive. So this P obviously is going to have a clockwise moment about C. F and N will have no moment, they are passing through C. And this mg sin theta will have counterclockwise moment about C. So about C, we are going to have P multiplied by this distance minus mg sin theta multiplied by this distance, right or not? How much is this distance? Capital R minus small r. This distance from O to C is capital R, and this is the small r, right? The distance at which P was acting. So this distance is capital R minus small r about point C. So P multiplied by capital R minus small r, which is going clockwise in the same direction, minus mg sin theta multiplied by capital R. So this is what we have written here. This minus W R sin theta, right? W is nothing but mg sin theta. So mg sin theta multiplied by R. That's what we have written here. And P multiplied by capital R minus small r. This is telling you what? The net moment about point C. This force has no moment, friction force, and N has no moment, mg cos theta has no moment, right? So these are the only two valid forces when you take the moment about point C. That's the beauty of this approach, that it simplifies the process by not considering the friction force at all. Multiplied by delta T. Delta T we know 5 seconds, correct? IC value we have already calculated. And now coming to delta omega. Delta omega, as I talked about magnitude only of delta omega, right? But please note, now we have to take it everything correctly with sign. There I was only trying to explain you. Here I was only trying to explain you that how we can maybe reach the velocity v, right? That's why I did not discuss about the sign. But here let's do it the proper way. Obviously we are going to discuss the sign. So here delta omega is going to be, again, alpha is in this direction, so and that direction is considered positive. So for omega also, this is the positive direction, this is the negative direction. Got it? Now delta omega is what? Delta omega is what? Final angular velocity minus initial angular velocity. Are we aware about the final angular velocity? No. What we know, that this central point will have some velocity v. That velocity v can be in this direction, can be in that direction, right? If this wheel is moving in such a way that it has started rolling upwards, v will be in the upward direction. And if it is rolling in such a way that v is in the downward, then v will be in the downward direction, right? About the point C, if we analyze that, if we analyze omega, then omega about point C will depend upon V at point O. If V is in this direction, final omega will be like this. If final velocity is in this direction, omega will be like this. We don't know yet, right? So what do we do in such situation? We assume any direction as the direction of V, and according to the selected notation value we can put. So suppose, assume that it is going to be in the upward direction, right? In that direction, V. Got it? About C, that V will be positive because V multiplied by R clockwise. So what we will write here? V divided by R. Sorry, V divided by R, not multiplied by R, because V is equal to R omega. So V by R is equal to omega, right? So here V by R is going to give us the final omega. This is with sign, considering the velocity to be in this direction. Ultimately, if V comes out to be negative, then we will know that final velocity is in the downward direction, right? Minus omega 1. Now omega 1 is known to us. How? Because V is known to us. V initially, as we can see here, is in the downward direction, 0.3 value. So about point C, we know that this is the direction in which V is existing, correct? And it is counterclockwise. So this sign will be negative. Not this, but this sign will be negative. Getting the point? Very small things, but these will cause you silly mistake. You will do silly mistakes at such points. If sign notations you are avoiding, ignoring, you are not paying attention to that how I am selecting the notations, because all these things obviously they are, these things have been told to you in theory. I think long back from school you are listening to this. Even in all the, I'll say all the subjects where you have to do this, whether it is strength of materials, engineering mechanics, theory of machine design, fluid mechanics, heat transfer, thermodynamics, everywhere plus minus sign is important. Getting na? Everywhere. But still in some question, some of the students will forget about that. They won't bother about the sign. Sign is very important, right? Any sign can make the biggest number the smallest number, right? It's all about the sign, correct or not? Value also and your marks also. So please note that if you want to avoid negative marking, please take care of the sign, plus and minus sign, right? Otherwise gate will not take care of your sign and will give you minus sign. So here omega 2 minus omega 1. Omega 2 here we have taken as positive because we have chosen that in this direction, clockwise, same as alpha, so positive. But this one was in the counterclockwise direction, so we chose as negative. And this is delta, so it will be difference of both. Putting everything here, please note I have not put the value here so far. I am only written omega 2 minus omega 1, correct? This ultimately is going to be with a minus sign. V naught is going to be with a minus sign. So I have written only the difference here. Got it? Now let's put the values here. So we know the value of P, 10, capital R 0.08, small r 0.03. Weight we already calculated, if you check here, 19.62, right? mg basically, m is 2, g is 9.81, r is again 0.08, sin theta is sin 15, delta t is 5 minus 0 or 5. Here IC value 0.02 we calculated already. V by r, V is not known to us, final velocity. This V we have taken with a positive sign because we assumed it to be up the incline. If we get the answer in positive, we solve it, we get the value of V as positive, it means that the direction that we selected was correct. If answer comes out to be negative, means final velocity will be downward direction. We considered above, but it is in the downward direction. Got it? Minus, here it is already in the counterclockwise direction, this VO, as I explained you. So here it is going to come with a minus sign. Both denominators are going to be radius r, right? From the point of velocity O, center point, to the point of contact, that distance is r, correct? In this entire equation, V is the only unknown, everything else is known to you, right? So all you need to do is just simplify this equation, and ultimately you are going to get the value of velocity as 1.575 meter per second up the incline. How? Because answer is coming out to be positive, means the direction of V that we assumed up the incline, that is correct because it is coming out to be positive. This is one way of solving the question. This is one way of solving the question where we have not considered the pure rolling concept of separating translation and rotation. Rather, if you look at it, nowhere we have applied the translation equation. Summation of force is equal to MA, nowhere we have applied, right? Rather, we have considered this problem as a problem of angular momentum about point of contact. And that's how we have solved this. But please note, this was a problem where we could do that, right? It is not possible that to do it in every question. So if you have a proper rolling question, use the rolling concepts that we have discussed, right? In fact, in this question also, if you just go by the rolling concepts, you will be able to get to the answer. And the next approach that we are going to discuss is the same approach. There, obviously, you need to find out not only the direction but also the magnitude of friction force. Only after that you can proceed and write the equation of translation and rotation about the center O. Let us move to that approach. So have a look at this free body diagram again, similar to the one that we have seen in the previous method, with one small change. Can you find the difference? Can you find something different in this free body diagram? Pause the video, think. You remember that when you used to be a kid, there was in newspaper there will be a puzzle where two images will be given to you side by side and you have to find out the difference. So consider it to be the same problem. Can you find it? This part here, acceleration. It was not shown earlier because we did not consider acceleration, because we considered the problem to be a problem of rotation about point C, correct? But here we are moving by the usual approach of pure rolling, where we will be considering acceleration as well as angular acceleration. So breaking down the problem of pure rolling firstly into translation and then pure rotation about the center O. For the translation case, we are going to have force balance along the plane, along this direction, since it is moving in this direction. So this is the direction along which we are going to apply the force balance. This approach we are going to do slightly quicker than the previous approach, because we have already discussed all these cases, with other examples as well as in theory. So summation of force is equal to mass multiplied by acceleration along this incline. Now along this incline, what are the forces acting? This is not going to come because this is exactly perpendicular to the incline. You take the cos component, it will be 0. So this is not going to come. This will come, P will come, F will come, correct? So if we consider this direction as positive, right? So what will happen? P minus mg sin theta minus F is equal to mass multiplied by acceleration, correct? That's what is going to be written here. P multiplied by F minus mg sin theta is equal to ma. Value of P known to us 10. F is not known to us. Again, I will tell you, if you want an explanation for that. I am not sure whether F will be in the downward direction or not. I don't know, right? Rather, I will tell you that even if you were not sure whether F will be 0 or it will exist, although we have explained that, although that concept has been deeply discussed with the special formula, that how to find out the value of F. Still, if you were unsure, there also you can take this value of F and ultimately you can see whether the value is existing or it is not going to exist. But it's a basic concept that, as per our discussion, should be known to you. It can be asked to you, directly as a theoretical question also. If question says pure rolling, guaranteed friction will be 0. No, it may or may not exist. Depends upon the configuration of force, right? So here P minus mg sin theta minus F. That this direction of F we have chosen on our own. As I told you, we need to find out F by here. To find out velocity, we need to find out F. We will see if this friction value comes out to be positive, means this direction that we chose was correct. If this comes out to be negative, means actual friction is in the upward direction, up the incline, correct? So here putting all the known values. So this is 10, this is F unknown, M is 2, G is 9.81, sin 15 is equal to mass is 2, acceleration is A. And here now we'll just simplify. All the values are known. only F and A are unknown, right? So if you simplify, this is the equation that you are going to get. Let's call this equation number 1. What we have got by applying the force balance along the incline. Similarly, now move to the next step of rolling analysis, where we do the rotational analysis about the point O. So here, applying the moment balance about center O. Net moment about O is equal to I naught alpha. Again, clockwise we are taking positive about O. So what are the moments that are going to contribute to the clockwise rotation? Obviously not this one, because it is passing through the center only. Not this one, because it is also going to pass through the center. Only P and F. Only these two forces are coming, right? So about O, clockwise is F multiplied by R. This is counterclockwise, P multiplied by small r, right? So net clockwise moment about O is equal to F multiplied by R minus P multiplied by small r, right? Is equal to I naught, a value known to us, mk square, known to us, right? And alpha is A divided by R. How did we write that? The rotation concept, alpha is equal to A is equal to R alpha, V is equal to R omega, A is equal to R alpha. Please note, we are just considering it to be performing a rotation about O. That's how we have broken down the rolling, translation and rotation about O. Here, F is not known, R is known, P is known, small r is known, M, K is known, capital R is known, A is not known, A is unknown. So again in this equation, F and A are unknown. Here also F and A were unknown. So we can solve the two equations and get the value of the two variables. So here we will put the value, R is 0.08 multiplied by F, P is R is 0.03, P is 10, is equal to mass is 2, K is 0.06, given in the question 60 mm. So square, A unknown, R again 0.08. Now you just need to simplify this equation, and ultimately you are going to get this as your second equation. So you have got two equations and two unknowns, F and A. Simply divide both of them. We divided them, A and A will be gone, so only F is going to be remaining on the left hand side. Now just solve it, and ultimately you will get the value of force of friction as 4.172 Newton. Positive, which means that friction direction that we have chosen is correct and its value is 4.172. Please note, we avoided all this calculation, right? All this calculation, force calculation, moment calculation, solving the equation. These all are calculations that you will have to do. They will require some time to solve, and possibilities of mistake increases. More are the number of steps, more is the calculation, more is the possibility of mistake. So now you have reached the point where you found out the friction. Everything we avoided by choosing the method 1. And if you know the value of F, put it in any of the equation 2 or 1, you will be able to find out the value of acceleration as well, which will come out to be 0.375 meter per second square. So what are we trying to do here? Let's understand. We found out the value of F, and from that we found out the value of acceleration. But why? Why are we doing it? Right? You should always have some idea and some clarity in mind that in which direction are we moving and why. You don't have to just scribble your answer on the scribble pad. The name of the pad is scribble pad. Does not mean you just have to scribble only. You have to think, and you have to thoughtfully do the steps, thoughtfully take the direction. We chose this way because in this way acceleration A is going to come. Acceleration A will help us in finding out the velocity V by the equation of motion. In the equation of motion, because here you have been given that for 5 seconds force is going to act. So T is known to you, 5 seconds. Initial velocity is known to you. Final velocity question is asking. So if you find out the value of acceleration, considering the center point, the center of gravity of this wheel, if we apply that to the center of gravity, the equation of motion, we will be able to find out the final velocity. That's the idea behind this. That's why time is known to us, initial velocity known. To find out final velocity, we require acceleration. To find out acceleration, we need to do force analysis as well as the rotational analysis, basically the pure rolling analysis. And after that, we will be able to find out acceleration, which we have done here. And now applying the equation of motion. From equation of motion, V is equal to U plus AT. V is the final velocity, not known to us. We need to find that out. Initial velocity is known. Minus sign, important, right? Because initial velocity is in this direction. But here, what we have chosen? Here what we have chosen, this direction is positive, right? Everything going up we took as positive. Acceleration, forces, velocities, right? In this direction positive, downward direction negative. So here u was in the downward direction, so with a minus sign. Again, small things which can cause errors. Plus a we have found out 0.735 multiplied by t is time of 5. So all you need is to solve this and you will notice that you have got the same answer as the previous approach, 1.575 meter per second, and here also 1.575 meter per second. Same answer you have got using this approach as well. But it's not over yet. There is another way, yet another way in which you can solve this question. Obviously, that will also require you to find out this value of force. Why? Because if we are not choosing point C and doing the analysis, if we are not choosing the point of contact and doing the analysis, obviously force will come now. Force of friction, how it will not come? Only if you chose point C, and that too for a moment, only then force of friction will be gone. Otherwise, whatever else approach you use, force of friction will come either in the form of force or in the form of moment, right? The next approach, the third method that we are going to discuss, is going to have again this force, because there everything we do till this point is going to remain same. But after that we are going to use the work energy theorem. Rather than using the concept of equation of motion, we are going to use work energy theorem that will lead us to the right answer.